Hello and welcome to Honors Function. In this lecture, I will remind you of the definition and property of radicals. Let's start with the first type of radical, a square root. So given a real number, so let's take a in R, and let's assume that a is positive or equal to 0, a non-negative real number, I should say. What do we call a square root of a? So a square root of a is a solution to the equation x squared equals a. A square root of a is a solution to this equation. Let's take a concrete example. For example, what do we call a square root of 25? A solution to this equation, okay? This equation has two solutions, right? You have x equals -5 or x equals 5. So -5 and 5 are called a square root of 25. Now, 5 plays a special role. The solution that has the same sign as 25, so in this case positive, 5, the positive solution is called the principal square root. And we use a special sign for it. We use this sign. And now you have to be very careful, okay? Because this is an abuse of language that can lead to some confusion. This is the principal square root of 25, but we do not read it like that. Usually when we read that, we'll say square root of 25. Now we know what we mean when we say square root of 25, but it's an abuse of language because a square root of 25 should be the solution to the equation x squared equals 25. Okay, so you get two square roots of 25. The positive one is called the principal square root of 25. So by definition, this symbol is always positive. So if I write this or equal to 0, okay, if I write this, this means nothing. This is always true by definition of that symbol right here. Okay? All right, let's go over some examples. Number 1, what are the square root of 16, I'm sorry. What are the square root of 16? Well, 16 has two square roots, okay? The solution of the equation x squared equals 16. This equation has two solutions, x equals plus or minus 4, okay? So 16 has two square roots, plus or minus 4. What is the square root of 16? Well, by definition, it's a positive solution of x squared equals 16. So by definition, square root of 16 is 4. Alright? Please do number 3 and number 4 on your own. Let's continue. Now that I have defined a square root, I would like to define an nth root. So what is an nth root of a number? So this time I will take a real number and I will not assume that it is positive necessarily. Okay, this time I will just take a real number. What do we call the nth root of a? An nth root of a is a solution to the equation xn equals a. Okay, a solution to this equation, the solution is called an nth root of a. That's it. That's all. Okay. Now, this equation may have one or two solutions depending if n is odd or even. The solution that has the same sign as a is called the principal nth root of a, okay? So this equation may have one or two solutions, okay? The solution, in case it has two solutions, or even maybe this one, we'll see. The solution has the same sign as a. If a is positive, I want the positive solution. If a is negative, I want the negative solution. This solution is called the nth root of a, and we denote it by nth root of a. That's it. So the nth root of a is not necessarily positive or negative. It will have the same sign as a. Okay? Let's go over some examples. So, what is or are the cube roots of -8? So I want the cube root, therefore I'm looking at the equation x cubed equals -8. Now I know how to solve this equation. I know this equation has only one real number solution, and it's x equals -2, right? If you cube -2, you find -8. Alright, that's it. So the solution is the cube root of negative 8, there's only one here, there's only one. The cube root of negative 8 is negative 2. What is a principal cube root of negative 8? Well, negative 2 and negative 8 have the same signs. Therefore, the cube root of negative 8 is negative 2. Okay? All right. Please do number 6, and I'm going to cover number 7. By definition, what does the fourth root of negative 81 means? Well, the fourth root of negative 81 is the, so I gotta underline this, the solution to the equation x to the fourth equals negative 81, sorry, with a negative sign. So we want the solution to this equation that has a negative sign, right? Negative sign because negative 81 has a negative sign. Well, this equation cannot have a solution in R, okay? There is no solution to this equation in R. You cannot find a number that when raised to the power of 4 will give you a negative number. That's not a real number. It's a complex number, but it's not a real number, okay? Therefore, this has no value. The fourth root of negative 81 has no meaning, okay? All right. Let's move on. So I think after that, I cover a couple of properties that are fairly natural. You should have used them plenty of time before. Here, let me read them in plain English. The x root of a product is a product of the x roots, okay? The x root of a ratio is the ratio of the x roots. Now, to say this, I'm assuming that all the roots are real number, okay? We have to be careful here. Let me just go with the square root, okay? The square root of negative 4 times negative 9 is well defined. What is negative 4 times negative 9? It's 36, and the square root of 36 is 6. But I cannot have an equality here because this is not equal to the square root of negative 4 times the square root of negative 9, okay? Because these have no meaning with real number. You have a complex number. So that's why I wrote here when all the roots are real numbers, okay? So the roots of a ratio is the ratio of the roots. This is really, there's nothing to say here. This is a definition of this symbol. If you take the x root of a and you raise that to the power of x, you're going to find a. Why? Because by definition, the x root of a is a solution, so I'm going to call my variable t, okay, is a solution to the equation t to the x equals a. Okay, that's the x root of a. T to the x equals a. So if I grab a solution and I raise it to the power of x, I'm going to find a, okay, by definition. This is the same thing as if I were to ask you, what is the color of the white horse of Henry IV? What is the color of the white horse of Henry IV? Well, the answer is in the question. Okay, this one, I'm not going to explain this one. It'll make sense when we're going to cover rational exponent. There will be a little proof right here to do. I'm not sure we're going to be using it right here. We'll make sense of this one with rational exponent. It's coming at the end of this video. Now this one, I want to stress this one. Look, I'm going to circle it in red. This is often a source of confusion for students. They will regularly forget this. And this plays a minor role in calculus, actually. Okay, this plays a minor role in calculus. It sometimes allows you to make some computation easy to do. Okay, sometimes. Let me explain to you this one. It has to do with what I went over right here. For example, look, if you have the fourth root of negative 2 to the fourth, well, you can't say that this is negative 2. It makes no sense, okay? Negative 2 to the fourth is 16. The fourth root of 16 is the solution with the same sign as 16, right? This is a principal fourth root of 16. So this has two solutions, right? X to the 4 equals 16 has two solutions. You got x equals negative 2 or x equals 2. But by definition, the fourth root of 16 has the same sign as 16. So it's got to be positive. So it's a positive 1, okay? So this has to be 2. Hence, we put an absolute value Now, if it's a number, there's no problem, right? If it's a number, I see it. I don't need this kind of work there. If it's a number, it's duh. It's when you're dealing with some expression that you have to be very, very careful, okay? So we'll see if you remember that by the end of this video. I'm trying to give you some hints there. By the end of this video, I've set up a trap for you to fall in. We'll see how many of you are going to avoid it. Let's apply this property right here. This should be a review, okay? So I'll do the first one and we'll see which one you'll do. I'll do number 8. The square root of 54. So I'm looking for the squares in 54. 54 is what times what? It's 9 times 6. Okay, 54. And therefore it's 3 root 6. Why? Okay, let's detail here if you want to. The root of a product is the product of the roots right here, and square root of 9 is 3. Alright, but of course you don't need to do that. You can do it directly. A cube root simplifies cube. You need to find your cube in 54. I'm gonna let you do number 9. Okay, and I'm gonna let you do number 10 also. Let me remind you how to rationalize here. Okay, so I want to rationalize the denominator. Please read my problem. Sometimes you're going to have to rationalize numerators, okay? So I want to rationalize the denominator here. Please don't do this. That would be brutal. That would be very prehistoric. Don't do things like that. Be a little bit more subtle here. That would work, but you would have to simplify a lot. Before you multiply both sides by root of 24, simplify your root. So this is equal to, let's take with the same color, 6 over, now 24 is 4 times 6. My square is right here. It's a 4, right? So it is 2 root 6. Now look what's going on right here. First, I can simplify my 6 and my 2, right? And now, instead of multiplying both sides by root of 24, I'm going to multiply both sides by root of 6. That's it. That's a little bit more subtle here. So what do I have at the top? 3 root 6. What do I have at the bottom? Root 6 times root 6. That's a last property right here. Oh no, it's not the last. It's number 3. It's a duh property, the one that is trivial. Okay, this is 6. And so we can simplify one more time. 3 by 3, 1. 6 by 3, 2. Root 6 over 2. Please do number 12 and number 13. I will do number 14. So, in number 14, you have to rationalize the numerator. It may be the first time you see this kind of problem. I will explain to you in class why actually this kind of rationalization is the most useful in math. Not to rationalize the denominator, but to rationalize the numerator. Again, it's something that shows up in calculus. We need this in calculus, okay? So this technique is the same technique as when you need to rationalize a denominator, okay? I'm going to multiply both sides of this fraction by what we call the conjugate of the numerator. So it's 2 plus root 6. 2 plus root 6. Of course, what you do at the top, you have to do at the bottom, okay? Now, I know my formula. A minus b times a plus b is a squared, 4, minus b squared, 6, over, do not expand here. Remember, don't expand the denominator. 4 times 2 plus root 6. So at the top, what do you have? You have negative 2 over 4 times 2 plus root 6. And here, that's why I didn't need to expand my denominator, because I can simplify here. 2 by 2, 1, 4 by 2, 2. And so the answer is negative. I put the negative sign in front of the fraction bar usually. Negative 1 over 2 times 2 plus root 6. Again, you do not need to expand the denominator, okay? All right, let's continue. I'm going to do 15, and you will do 16. The positive solution of the equation x squared minus x minus 1 equals 0 is called the golden ratio, and it is denoted by phi. This is phi. Show that the other solution is negative 1 over phi. To do that, well, I need to solve the equation, okay? I'm going to use a quadratic formula. So let me remind you of the quadratic formula. It is negative b plus or minus b squared minus 4ac over 2a. All right, let's use it here. So x equals, so negative b, so b is negative 1, so it's 1 plus or minus square root of b squared, negative 1 squared is 1, minus 4 times a times c, careful right here, it's negative 1 for c, right? And all over 2a, 2 times 1, 2. Alright, so I have 1 plus or minus square root of 1 plus 4, 5 over 2. Okay, which one is phi? Which one is phi? The positive solution. So phi is 1 plus root 5 over 2. I hope you did not hesitate here, okay? 1 minus root 5 over 2 is not positive, it is negative. Now, I'm asking you to show that the other solution, so what's the other solution? 1 minus root 5 over 2 is the same as a negative reciprocal of 5. Well, what am I asking you to show? Well, let's look at the negative reciprocal of 5, right? What's a negative reciprocal of 5? This, right here. So it is negative. How do you take the reciprocal of that? Just flip it. Negative 2 over 1 plus root 5. So I'm asking you to show that negative 2 over 1 plus root 5 is actually the same thing, and I'm going to put a question mark because you have to show it, as, what's the other solution? It's 1 minus root 5 over 2, okay? So is it really the same? 1 minus root 5 over 2. Is it the same? Let's check it out. All right. How do I go from here to here? Well, hey, look, I mean, you have a root there. You don't have a root there. How do you get out a root at the denominator? You rationalize it. All right, let's do it. So let's rationalize the denominator right here. 1 minus root 5, 1 minus root 5, and let's see where we land. So the negative sign in front right here. At the top, I am not going to expand this time. I hope something will be nice and something will simplify. 1 minus root 5 right here. What do I have at the bottom? Again, I know my formula. A minus b times a plus b is a squared, so 1 squared is 1 minus b squared, 1 minus 5. So what is that? So we have a negative sign. 2 times 1 minus root 5 over negative 4. Check this out. The 2 negative will cancel. This will simplify to a 2. And what do we have? Oh, lo and behold, 1 minus root 5 over 2. Checked! Alright? Please go over the next one, go over 16 for the silver ratio. I am also showing you a notation for the silver ratio. Finally, let's finish with a notation. So this is a notation for a rational power. So I want to give a meaning to, for example, 3 to the 1/2, or 5 to the 1/3, or 7 to the 2/3, for example, okay? Well, 7 to the 2/3, I mean, this is going to be very simple. If I can give a meaning to the 1/3, to the 2/3, I'll do this, right? 7 squared to the 1/3. I know what 7 squared is, so basically, the main quest here is give a meaning to this kind of power. So, what can this mean? All right, look, what happened if you square it? What happened if you square 3 to the 1/2? Well, you know what you're supposed to do with exponent. You're supposed to multiply them, right? So this should be 1/2 times 2. Well, what is 1/2 times 2? It's just 1, right? So it's 3 to the 1, which is 3. So look, if I square this thing, which I don't know what it means yet, I find 3. What do you call that? What do you call a number such that when you square it, you find 3? You call it the square root of 3. So it makes sense to give a definition to 3 to the 1/2 to be just the square root of 3, and that's a definition. Likewise, for the 1/3, if you raise that to the power of 3, you will find 5. So what number raised to the power of 3 give you 5? The cube root of 5, right? That's a number. If you raise this one to the power of 3, you're going to find 5. So I'm going to give this definition to 5 to the 1/3. Now, of course, I don't stick with these bases right here. In general, by definition, a to the power of 1 over n is the nth root of a. Now, I'm sure you worked with that before. This is called the radical notation, while this is called the rational exponent notation, or just the exponent notation, okay? Anyway, I'm gonna do the last example, number 18, and you will do number 19. Alright, so without using a calculator, you have to figure out this value right here. So I'm going to be using some properties of exponent here. If I do negative 32 to the 3/5, I have two possible ways of getting at the number. I could do negative 32 cubed and then take the fifth root, but this is with no calculator, right? I'm sure maybe one or two of you can just right away tell me what 32 cubed is. I can't. So how about the other way? Well, that's going to be a bit better. I can do power 1/5 first and then cube that. Now, I expect you to know your powers for the bases 2, 3, 4, and 5 up to, for the base 2 maybe up to 6, for the base 3 up to 4, for the base 4 cubed and 5 cubed. These have to be fairly automatic, okay? And of course all the one before. They have to be very automatic. So I know that 2 to the 5th is 32. So the fifth root of negative 32 is negative 2, and negative 2 cubed is negative 8. Alright, you do 19. Thank you for watching.